Hi guys, welcome back. We're going to go ahead and start our notes in section 2.2, graphs of equations in two variables. The majority of this is review. There is just one thing on symmetry that will be new as we get to the third page. Okay, so ordered pairs are when you plug them in for x and y, it makes the equation true. So there's lots of answers. So that's the solution of an equation. And then you can graph all those solutions. So those are points. You can graph a set of points and make a line. Important points are the x-intercept and the y-intercepts. X-intercepts is where it crosses the x-axis, and the ordered pair is x comma 0. Y-intercept is where it crosses the y-axis, and the ordered pair will be 0 comma y. That's also how you have to type it into Math Excel. You have to use a parenthesis in the 0, etc. So I'm going to change this problem. It says write down 3 solutions to the equation y equals 3x plus 6. We're going to go ahead and make that. Makes it a little bit nicer when we graph it. So you can make a table, pick any points that you can plug in. So if we do x, y, and let's say I plug in 0 for x. 3 times 0 is 0, plus 6 is 6. Then I'm going to plug in the point, let's say 1. 3 times 1 is 3, plus 6 is 9. I could plug in -1. 3 times -1 is -3, plus 6 is 3. So you could pretty much plug in anything. This is just 3 points that I did. There is an infinite number of points that you could plug in. And that's why a line also has arrows, because it continues in both directions. So how many solutions are there? An infinite many of solution. So once again, I'm going to go ahead and change this problem to a 6. It says graph the equation. So up to you how you want to graph it. You can use the table we just made, or if you think back to your Algebra 1 days, this is just a straightforward example of y equals mx plus b, where m is your slope and b is your y-intercept. I think that's the easiest way to graph it, but you could make a table. So 6 is the y-intercept. So I would start at positive 6. The slope is 3. A positive slope means up and right. When I can't go up and right anymore, I can go down and left. So a positive slope up and right and down and left. So I'm going to stretch it out and make a line. And notice that the points that I have in the table, 0, 6, 1, 9, and -1, comma 3 are all actually on the graph as they should be. The x-intercept is where it crosses the x-axis. So your x-axis is right here. So it's that point. So I'm going to go ahead and say that the x-intercept is -2 comma 0, because again, you have to write it as a point. And then if we go ahead and look at the y-intercept, that's where it crosses the y-axis there in pink. So I would go ahead and I would write that as 0 comma 6. If you put the number in the wrong spot with the 0, it will be marked wrong. You can also find them without a graph. So we'll take a look at that. And it's going to have to do with plugging in points. So let's practice plugging in points first. So it says, is 5 comma 8 a solution? Well, to see if something is a solution, you're going to go ahead and plug the point in. This is x and y. So I'm going to say 8 I'm going to plug in for y, 5 I'm plugging in for x, and I want to see, is this equation true? 3 times 5 is 15. 15 minus 10 is 5. So no, it's not true, because 8 does not equal 5. This is not possible. I'm going to erase that x. It looks like so it's not true. If it said 8 equals 8, then yes, it would be a point on the graph. So we're going to use the idea of plugging in points to find intercepts. So to find an intercept, very easy, you're going to set the y value equal to 0 and solve for x. Okay, so let's go ahead and take a look for that. So to find the x-intercept, we're going to go ahead and plug 0 in for y. So we're going to say 0 equals 2x squared minus 8. And I'm going to solve for x. So I'm going to add 8 to both sides. Then I'm going to divide by 2. And then to get rid of the x squared, I'm going to have to go ahead and square root both sides. So x ends up being plus minus 2. Remember, when you square root both sides, you must put a plus minus sign. So the x-intercepts are 2 comma 0. And we also have the point negative 2 comma 0. So both of these are our solution. Math Excel, when you type in the answer, is going to have you put commas between your points, okay? Let's go ahead and take a look at the next part. The next thing says, for a y-intercept, set the x value equal to y, set the x value equal to 0 and solve for y. So same idea for the y-intercept, except now the 0 is being plugged in for x. So when I solve that, I'm going to get y equals 2 times 0 squared is 0. 0 minus 8 is negative 8. I'm going to write it as a point. That's going to be 0, negative 8, with my parentheses around it. Okay, straightforward, algebra 1. The next thing we're going to talk about is implied parentheses. So there's always a parenthesis around a variable. So this x squared here means there's a parenthesis around it. It's not around the negative. If it wanted to be around the negative, they would have to put a parenthesis around the negative. There's always an implied parenthesis when you have more than one thing in the numerator of a fraction bar. And then same thing with the denominator. So each part is separate from each other. So it's like there's imaginary parentheses there. Under a radical, those two pieces go together. Also around absolute values. And then finally, the expression in an exponent. Notice here though, if they wanted the negative sign included, you'd have to have parentheses around the negative. If they don't include it to begin with, then it's just the 16 that's in parentheses. That would end up being a negative number. So let's go ahead and again do some basic algebra 1 graphing before we get to the more complicated stuff. Let's review this. It's been a long summer. So y equals 2x minus 5. Again, I would probably just go back to graphing y equals mx plus b. But it does say by plotting points, you can plot points from y equals mx plus b, or you can make a table. But again, I think this will be the easiest way. If you want to make a table, just plug in values. 2 times 0 is 0, minus 5 is negative 5. You could plug in 1, 2 times 1 is 2, minus 5 is negative 3. You could plug in positive 2. 2 times 2 is 4, minus 5 is negative 1, and then you could graph those points. Again, I'm going to go ahead and do y equals mx plus b. So here I know that the slope is positive 2. And b, the y-intercept is 0, negative 5. So 0, negative 5, I'm going to make a point. And then I'm going to count the slope up to right 1. A positive slope is up and right. You can also go down and left. And again, these points are going to be the same points if you made a table here. For instance, look at 2, negative 1. 2, negative 1 is right here. So you would get the same thing using either method. Let's take a look at part B. Part B is y equals x squared. So hopefully in your mind, you're thinking quadratic, right? Because it has that x squared there. So this is a quadratic one. So here you could make a table. So you could plug in 0. 0 squared minus 4 is negative 4. You could plug in 1. 1 squared minus 4 is negative 3. You could plug in 2. 2 squared minus 4 is 0. And I would try some negatives, although hopefully in your mind you're already thinking a U shape, a parabola, because it's quadratic. Negative 1 squared is positive 1, so 1 minus 4 is negative 3. You plug in negative 2, negative 2 squared minus 4. Negative 2 squared is 4. 4 minus 4 is 0. So there's a table. I'll also show you how to graph it with that one. So we've got 0, negative 4, 1, negative 3, 2, 0. Negative 1, negative 3, negative 2, 0. And that is our U shape. How could you have graphed it without it? If you remember from your core graphs from Algebra 2, it was a U shape, and the U shapes start at the, oops, that does not start at the origin there. Remember, a U shape starts at the origin, and it's the point 0, 0, 1, 0, 2, 4, and then it's reflected on the other side. But since this one says -4, you would have had to move the whole graph down 4, and you would get the same graph. Okay, so just kind of showing you both ways. We'll get way more into the core graphs later on. That will be a big, big topic for college algebra. So totally fine to use tables right now. Okay, so if we continue to look, the new part I talked about was going to be the symmetry part. We're going to be testing for symmetry. Something can be symmetric among the x-axis symmetry. So here's your x-axis. Notice that the graph is exactly the same on top of it as it is on the bottom. It's like a mirror reflection. You're going to find if something is x-axis symmetric by either looking at the graph, or algebraically, you're going to plug in x comma negative y and see if you get the same equation. If you do, then it's x-axis. You're also going to go ahead and check for y-axis symmetry. Y-axis, notice how the left side is the same as the right side. That's called y-axis symmetry by visually looking. And in this case, algebraically, we're going to plug in the point negative x comma y. And if we get the same equation back, then it's going to be symmetric. And then our third case over here is origin symmetry. And that's going to be reflective across the origin. So it kind of goes in a whole 180 degrees here. So it kind of goes around and circles all the way through here. So what happens is the negative x comma negative y, when you plug in, you're going to get the same equation back, okay? But again, if you kind of imagine turning this around through both axes, you're going to see that it lands on top of each other, okay? You might be wondering, why are those the points? And that is because this is reflective for the x-axis. If this is x comma y, the reflection point over the x-axis would still be a positive x, but now since the y is below, it would be a negative y. So that's why we use that point. And then for the y-axis symmetry, notice if you have positive x comma y and it's symmetric around the y-axis, when you flip it over, now the x is negative, but the y is still positive. And then in our last case over here, notice again, if you have a positive x comma y and you kind of rotate it all the way around into that diagonal quadrant, this would have both a negative x and a negative y here. So we're going to use that information. And we're going to start off with just one point and look at it visually. And then we're going to go ahead and look at it with some algebraic ways. So it says plot each point. So I'm going to plot my original point in blue. So 5 comma 0. This is my original point, okay? It's on the x-axis. They want me to go ahead and make it symmetric to the x-axis. So the x-axis means you flip it over the x-axis, but this point is already on the x-axis, so you can't really flip it over. So the first point reflecting it is still going to be on here, and I'm going to call that point A. Now we're going to reflect it over the y-axis. So my y-axis here, which I'm going to call this point B, I'm going to reflect over the y-axis. The y-axis is going up and down, so I need to reflect it to the other side. Notice that it's 5 spots to the right, so I'm going to count 5 spots to the left. So 5 spots to the left of the y-axis puts me right here, and I'm going to call that point B. And then lastly is the origin. So the origin, you're going to flip kind of all the way to the other side. It's going to reflect over the x and the y. So if you reflect A over the x axis, it still stays the same. And then you reflect it over the y, it ends up landing exactly here. And this is a special case because this point was on the x-axis to begin with. So that's why there's a lot of points on top of each other. So let's look at one where it's not really a special case. Let's go ahead and take a look at the point -4 comma 3. Again, I'm going to go ahead and graph that in blue, my original one. So negative 4, comma 3 is right here. The first thing I'm going to do is graph my x-axis, which is point A, so it's going to be symmetric to it. So think of your x-axis is right here. We want to flip it over it. We want to reflect over it. So it's going to have to come, oops, it's going to have to come down, okay? So notice that it's 3 above. So to find the exact spot, you're going to go 3 below. So I'm going to count 3 below, and that's going to be my point A. Now for the y-axis symmetry, this is my y-axis. It goes up and down. I want to be symmetric to it. So since it's on the left side, I need to flip it to the right side. So it's going to be somewhere over here. Notice from the y-axis, it's 4 spots away. So I have to count 4 spots away in the other direction. So 1, 2, 3. And that's my point B. That's my y-axis symmetry. And then lastly is the origin. Remember, the origin flips both points. So if it's negative 4, comma 3, it's flipping both points. So it's going to be 4, comma negative 3. So it flips over the x and the y if you're visually wondering what it does. So let me go ahead and change my colors here. So this one is going to first flip over here, and then it's going to flip again because it's symmetric to both. So it ends up being right here at positive 4, negative 3. Again, you can kind of quickly do the problems in the sense, if we take a look at the original, which is negative 4, comma 3, we already said that the x-axis symmetry is going to be x negative y. So the x stays the same, so the x would stay at negative 4, but the y now, which was 3, is now going to be negative 3. And another way to look at that, if we look at the pink one here, if we do y-axis, if you go back and look at the y-axis information, notice how I highlighted negative x comma y. So we've got negative x comma y. So notice with the original point, which was negative 4, if we take negative 4, it becomes positive 4, and the y stays the same. So notice when we graphed it visually, point B is also located at 4, comma 3. It should be the same thing. And then finally, if we do the origin, so if you take that point, notice for the origin, it's negative x and negative y. So if you take the original one, negative 4, and we do the opposite of that, that's 4. The original one was 3. The opposite of 3 is negative 3. Notice once again, C is located at 4, negative 3. So you can verify that visually as well as algebraically. Okay, so let's take a look at when you don't have a picture at all. And it says list the intercepts and test for symmetry. So we should be able to find the x and y intercepts. I'm going to start with that. So for the x-intercept, and don't write very big here because we've got a few different things to do. So for the x-intercept, you're going to plug 0 in for y. And we're going to solve. So we're going to end up with x squared minus 4 equals 0. I'm going to add 4 to both sides. So I get x squared equals 4. I'm going to square root both numbers, which means I have to take the plus minus of square root 4, which is 2. So my x-intercepts, which I must write as points, are 2, comma 0 and negative 2, comma 0. Now I'm going to go ahead and find the y-intercept. Y-intercept, it's the same idea. I'm going to go ahead and plug 0 in for x, though. So 0 squared minus y minus 4 equals 0. So I'm going to end up with 0 minus y minus 4 equals 0. Notice that the 0 minus 4 is just negative 4. So negative y minus 4 equals 0. Add that 4 to both sides. So I get negative y equals 4. Divide both sides by negative 1, and y is negative 4. So that's my y-intercept, 0, -4. Those are my intercepts. Now it wants us to go ahead and test for symmetry. So we're going to have to use those x's and y's and the negative x and the negative y, etc. So you have to know for the x-axis that that goes with x comma negative y. So you have to know that. So I'm going to start with that one, and I did green for that one. I'm trying to be fancy here and keep my colors straight. So if we're going to test for symmetry, we're going to start with the x-axis symmetry. So is it symmetric among the x-axis? Let's find out. For the x-axis, don't forget you're plugging in x negative y because it reflects over the x, so it changes the y here, okay? So in your original equation, you're going to go ahead and plug in x for x, and then you're going to be plugging in negative y for y here. That's what you end up plugging in. So what that looks like here is we're plugging in x for x, so x squared stays. You can use parentheses or not, up to you. And then the y, we're plugging in negative y. Whenever there's a negative sign, use parentheses. If it's positive, you don't really need to. But if it's negative, you need to use parentheses, okay? So I'm going to, just to make it easier, keep this as x squared minus negative y minus 4 equals 0. And we're seeing, do we get the same equation as what we started with? Well, negative minus negative y, this portion right here ends up being a plus y. So minus negative y ends up being a plus y. So when we look at this, we're looking to see, is this equation exactly the same as this equation? And the answer is no. Notice it says minus y instead of plus y, so it's not the same thing. So is it symmetric among the x-axis? The answer is no. Now we're going to try the next one. So now we're going to try y-axis symmetry. For y-axis symmetry, and this is something you need to know, you're going to plug in negative x, positive y. So again, what you're doing is we're taking negative x and plugging that in place of x. And then we're taking y here and plugging that in for y here. So what it's going to end up looking like is we're going to plug in, since I'm plugging in a negative x, I'm going to use parentheses, minus, I'm plugging in a y, minus 4 equals 0. And I'm going to simplify it and see if it's the same as the original equation. Negative x squared is going to be a positive x squared, because two negatives make a positive, minus y minus 4 equals 0. So I'm looking to see, is this the same thing as the original? So is this equation the same as this equation? And the answer is yes, they are the same. So this does have y-axis symmetry. So this is a yes for the y-axis. Now we have one more to go ahead and test, and that's going to be the origin. So to test for the origin symmetry, we're going to go ahead and plug in, you need to know for the origin, you're plugging in negative x, negative y. So same idea here, you're going to plug in negative x for x, and then you're going to be plugging in negative y for y, and you're going to see if the equation is the same. So we're plugging in negative x. So it's a negative, so I want to use parentheses. So negative x squared minus, it's another negative, so I'm going to use another set of parentheses. So I'm plugging it in. Negative x squared is positive x squared. Negative minus negative y, two negatives makes this a positive. So then I'm asking myself, is this equation exactly the same as this equation? And the answer is no. One is minus y and the other one is plus y. So this is not symmetric among the origin. So that's the work you need to show. Okay? So here, if I actually fill out my answers, my intercepts are 2 comma, actually, I'm just going to do an arrow because I'm running out of room. So these are my intercepts. Is it symmetric? It is symmetric only among the y-axis. That was the only one we found that the equation was the same. So it's just y-axis. Okay, let's try that again with the next one. So the next one says go ahead and find the x and y intercepts, and then we're going to test for symmetry. So we're going to start with plugging in 0. So for the x-intercept, we plug 0 in for y. So I'm going to go ahead and just say that's 4x squared equals 4. Divide by 4 to both sides, x squared equals 1. Take the square root of both sides. Make sure you take the plus minus sign. So you get positive 1 comma 0, and you're also going to get negative 1 comma 0. Both of those are intercepts. For the y-intercept, you're plugging 0 in for x, so that entire term is going to go away. 4 times 0 squared is gone. So we just have y squared equals 4. Once again, you're going to go ahead and square root both sides. So you're going to end up with plus minus 2. So whenever you square root both sides, you get a plus minus sign. So our points are going to be 0 comma 2 and 0 comma negative 2. Okay. And MathXL wants you to put commas between your points. So both of these are your answers to the intercepts. Okay. All right, let's look at the new part here. The new part is the symmetry. So let's start with the x-axis symmetry. So for the x-axis symmetry, you're going to plug in x negative y, okay? So I'm reading that from over here, but you've got to memorize that. You have to know that. So I'm not going to write down those same words. I'm just going to go ahead and do it. So x-axis, I've got 4. I'm plugging in a positive x squared, so I don't need to worry about parentheses. Plus my y I'm plugging in is negative, and I'm going to square it. So that ends up being a positive y squared equals 4, and then I check. Is this equation the same as this equation? Yes, it is. So it is symmetric. So this is a yes for the x-axis. Let's go ahead and check the y-axis. So the y-axis symmetry now. Now you're looking at plugging in negative x comma y, okay? So for y-axis, you're plugging in negative x comma y. So, oops. Since I'm plugging in negative x, it's negative, I'm going to use a parenthesis. Since the y is positive, I'm not going to worry about the parenthesis. You can use it if you want. Negative x squared is going to end up being positive. So what ends up happening, again, you're looking to see, is my equation, when I simplify, the same as the original one? The answer is yes. So then this is y-axis symmetry, or symmetric over the y-axis. All right, we've got one more to check, and that's the origin. So when I'm going to go ahead and check the origin, I'm plugging in, and again, if you want to look at what I put here, I'm plugging in both negative x and negative y in the origin, okay? So both of those values are going to be plugged in. So we've got 4 times negative x squared plus negative y squared equals 4. Negative x squared ends up being positive. Negative y squared will end up being positive. So once again, we're checking, is my simplified answer the same as my original equation? And the answer is yes, it is. So this one happens to be symmetric among all of them. So you can go ahead and circle all the parts. Okay. So we will do more practice with this in class on the warm-up, and then you will have to also do this in your Math Excel. So I will see you in class.